Hello, everyone. Today we will cover a very important topic in managerial computing, that is data management. Let's start by understanding the foundation of data management. Data is raw, unprocessed facts like numbers, names, or survey responses. For example, customer orders in a market. And then when we look at information is what you get after organizing and processing that data to make it useful and meaningful, like a sales report that shows which product sells out the most. Information gives meaning to data and helps managers make informed decisions. So, looking at data management is the process of collecting, organizing, storing, protecting, and using data effectively. And the goal is to ensure data is accurate, available, secure, especially for decision making. For example, if you are a manager of a hospital, you must keep accurate patient's record, protect patient privacy, and that record should be available for a doctor who is treating the patient. So now, why is data management important here? Informed decision making. Data enables managers to make strategic decisions. For example, mobile networks in Uganda analyze calls data to improve service coverage, operational efficiency. Organized data eliminates duplication and speeds up work. Example, a government registry using digital records can serve more people in less time. Enhanced customer experience. Banks use customer data to offer personalized products via apps like mobile banking, which give convenience to customers while accessing any financial service from their banks. Compliance and legal protection. Laws Data Protection Act require proper data handling to avoid penalties. Improved data security. Digital systems with clear access controls prevent data leaks and cyber attacks. Cost savings. Automated data systems help reduce manual tasks and storage costs. As we see that storing hard copy data is so hard and risky, where data can easily get distorted or even get lost. There are several building blocks of good data management, so let's look into it in details. Data collection, gathering data from forms, mobile apps, surveys, or sensors. Example, a farmer app like Eziagri collecting crop data from users. Data storage, data is stored in databases, cloud systems, or servers where schools use Google Drive for student records. Data processing, converting raw data into useful reports using Excel. Example, exam results processed into performance charts. Data access and sharing, who can access what? For instance, teachers access class scores, but only the head teacher edits final reports and then the students only view and submit exams. That is data access and sharing. Data maintenance, cleaning data to remove errors or duplicates and virus threats, crucial for accurate decision making. Data governance, policies for data use. We see that every organizations have different policies that govern data handling in their organization. For example, organization may require field staff to enter data in a uniform format. Data organization, structuring data into logical groups for easy retrieval, like separating files by project, date, or team. Let's look at tools that help manage data effectively. We start with the most basic tools. Microsoft Excel, widely used for small scale analysis like budgets and reports. Microsoft Access for medium level databases. Google Sheets, useful for collaborative online data sharing, especially in remote teams. Then we have also the advanced tools, database management systems, DBMS, like MySQL or Oracle, used by large institutions. Data warehousing, for storing large volumes of data, like national ID records. Extract, transform, load, ETL tools used in logistics or e-commerce to move and clean data between systems. Let's now talk more about protecting this valuable asset called the data. Data protection refers to the strategies, processes, and tools used to safeguard sensitive information or data. Here, we do not only look at sensitive information, but we need to protect any data we have. You never know what someone will be using that information for. So, data protection is just like how we protect our privacy at home. Not everyone passing along the road can access your bedroom. It's personal. And it's the same way with data. Not everyone should access your data. We need clear boundaries, privacy, and security to keep information safe, just like we do in our daily lives. There are three key principles in data protection: confidentiality. Only authorized people should access the data. Integrity. Data should be accurate and not changed without permission. Availability. Data should be usable when needed. Then why do you have to protect this data? Protects sensitive information, prevents identity theft or financial fraud, ensures legal compliance, meets data laws, avoiding lawsuits or fines. Clients have rights to open case if you lost or exposed their data. Maintains reputation. People trust businesses that handle their data well. So, to keep your reputation and clients, you should protect clients' data. Ensures business continuity. In case of disaster or hacking, data backups restore operations. So, with that, data is not just lost forever, but you still have a copy of the data. Reduces cybersecurity risks, prevents phishing, malware, or hacking attacks. There is a lot of cyber attack nowadays, so protecting your data limits the risks at which you are exposed to these cyber attacks. And then let's also have a talk about the techniques applied in the data protection. First, let's talk about authentication. And this is about ensuring only authorized people can access data. This is most used in banks. They use passwords, biometric scans like fingerprints, or even special access cards to ensure only tellers and managers can access customer data. This keeps sensitive information safe from unauthorized users. Next is encryption. This is like scrambling data into a secret code that only authorized people can unlock with a decryption key. For instance, mobile money services like mobile banking encrypt your transaction details. Even if someone intercepts the data, they can't read it without the key, protecting your money transfers. Regular backups. So, moving on. Regular backups involve creating copies of data stored in different locations. I think of a hospital using cloud backups for patient records. If a computer crashes or a virus hits, they can recover data from another secure location, ensuring continuity of care. The firewalls and antivirus software block malicious traffic and prevent software viruses. For example, a business might use antivirus software to protect their customer database from hackers, keeping their operations running smoothly. Then, talking about data masking and tokenization, hide sensitive data in non production environments. Like a call center handling customer queries, use this to protect personal details, replacing real data with fake but realistic values during testing. Finally, multi factor authentication, MFA. This adds extra security layers beyond passwords. Imagine an e commerce platform requiring a password plus a code sent to your phone, and this double check ensures only you can access your account. Now, let's look at best practices. Establishing a data management policy is key. For example, a telecom company like MTN setting rules for handling customer call records, ensuring compliance with privacy laws. Implementing strict access controls. This means limiting who can see data. For example, a university might restrict student records to only the registrar and authorized staff, using monitoring systems to track access. Training employees on data handling is crucial. For example, a company could train staff to recognize phishing emails, reducing data breach risks. Looking into classifying data based on sensitivity helps prioritize protection. A government office might label citizen census data as highly sensitive, applying extra security. Then, regularly updating software and patching vulnerabilities is vital. A tech startup might update its systems to fix security holes, preventing data leaks. Encrypting sensitive files and using secure networks for data transfer is another layer. An NGO might encrypt donor information before sending it over the internet. So, lastly, using secure passwords and rotating credentials keeps data safe. A manufacturing firm might enforce password changes every 3 months to enhance security. Let's talk about the applications of data management and protection. In the banking sector, banks use encrypted systems to secure customer transactions and data, ensuring trust. And in the healthcare systems, hospitals and clinics use electronic health records, EHR systems with access controls to manage patient data. Then, in educational institutions, universities use cloud based databases to manage student data and ensure secure access for staff and students. In government, national statistical bureaus store population and census data centrally. For instance, Bureau of Statistics uses secure systems to manage this critical information. In agriculture, farmers use mobile apps to collect and manage crop data. A cooperative might use a secure app to track harvest yields, improving decision making. So, to wrap up, data is a strategic asset. Good data management improves efficiency and security. For example, a well managed customer database supermarket can streamline inventory and boost profits. Protection ensures trust and compliance, while investing in these practices leads to long term success. As future managers, mastering data management will set you apart. With this, we have come to the end of our lecture. Thank you.